Okay, we're going to start off by saying that if, remember yesterday we said two triangles were congruent if all of their corresponding parts were congruent? If all the angles were congruent to each other, if all the corresponding angles were congruent and all the corresponding sides were congruent, well, then the triangles are congruent, or the polygons were congruent. Well, that's kind of a no-brainer, right? I mean, if two shapes are exactly the same, then they're congruent. So now you're going to learn a couple rules about triangle congruence, okay? The first one being side-side-side congruence. And what it says is that if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. Doesn't say anything about the angles, does it? All right, side-side-side congruence. If three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. So if you have this picture, and you had triangle MNO, and next to it you had triangle EFG. And you had this. And you are asked, are the triangles congruent? If so, explain why.
Yeah.
And write a congruent statement. Are the triangles congruent? If so, explain why and write a congruent statement. So we're looking at two triangles. We got triangle MNO, we got triangle EFG. We just said that if three sides of one are congruent to three sides of the other, then they are congruent. Agreed? So are the triangles congruent? Yes. So are the triangles congruent? So we're going to say yes. Yes. If so, explain why. Here's the why, okay? They are congruent by side, side, side. They are congruent by side, side, side congruence. You don't have to write the word congruence. If you say yes by SSS, that means that you are stating that these two triangles are congruent because all three sides of one are congruent to all three sides of another. That's the reason that they are congruent. Okay? So yes, they're congruent. By side, side, side is Y. And the congruent statement. When you write the congruent statement, we talked about this yesterday. You're going to say that triangle, you name the first triangle in any order of vertices that you like. Understand? You can name this first triangle. You have to use M, N, and O, but you can use those in any order. So I'm going to use the order M, N, O. Triangle MNO is congruent to triangle. Now, we practiced this yesterday. Since we called the one on the left MNO, Cariana, what do we call the one on the right? Okay, pay attention here. Look what we did. When we called the one on the left MNO, we started at M, right? And we went to N. So we went through the side with 3 tick marks. And then we went through the side with 2 tick marks. So we went through 3 and then through 2. So look what we got to do on the right. Don't we got to go through 3 and then through 2? Okay, so you got to go here to here. So what do we call the triangle on the right, Jason? GFE, good. And that's what needs to go through your head when you name the first triangle. And that's exactly the technique I want you to use. If I called the first triangle MNO, I started at M. I went through 3 tick marks and then through 2 tick marks. I went through 3, then 2. I got to go through 3, then 2. And the only way to go through 3 and then 2 is to start at G, go to F, and then to E. Does everybody understand that? All right, we're going to do one more. I'm going to change the order of the first triangle this time. Change the order of the first triangle to ONM. ONM is congruent to which triangle? Yes, sir. Very good, EFG. All right, second time I went through 2 and then 3. So I got to go through 2 and then 3. See it? What else did I do? Didn't I just reverse the order of the letters from the original? If I just look, MNO in red, ONM in black, so just reverse the order of the second triangle. Does that make sense to everybody? Okay. Now, where this gets a little bit more difficult is when you're asked the question this way. Is triangle ABC with A at 1, 1, B at 0, 3, C at 2, 5, congruent to triangle EFG with E at 1, negative 1, F is at 2, negative 5, and G is at 4, negative 4. The question continues. If so, explain why. And write a congruence statement. So since we're in the section dealing with side, 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 can anybody tell me what they think we need to do here? Somebody said find the slope. Any other ideas on what we might have to do here to see if these two triangles are congruent? Would the slope tell us if they were congruent? Rise over run. This is a higher order question. Yeah, Matt. Say again. You could plot the points. If you plotted the points, what would that tell you? It would tell you what it looks like. And what if they were very similar looking? How could you verify that they were, Jason? Unfortunately, isn't that what you have to do? Don't you need to just find the distance from A to B, B to C, and C to A, and see if that's the same as the distance from E to F, F to G, and G to E? That's what you have to do. As much as nobody wants to do it, that's what you have to do. Unless you were to graph them both and they were both right triangles. And if they were both right triangles, meaning they had a horizontal leg and a vertical leg, and the length of their horizontal leg and vertical leg was the same, then you know that their hypotenuse would be the same. So now, I've had some kids in the past that could find all those distances without graphing these. But I think what you need to do is you need to graph these, and then you need to use the distance formula, or are any of you using the Pythagorean theorem instead of the distance formula to find the side lengths? Much simpler, right? All right, so what I'm going to do here is I'm going to show you how to do this problem, because I'm pretty sure there's one of these on your quiz Friday. So we're going to graph these first. So before I draw my graph, I kind of look at my largest values. My largest x value is positive 4. And my y values go from, is that a 5, negative 5 to positive 5. All right, so that gives me an idea of the size of my coordinate plane. So we're going to graph this first of all. I'm gonna put it right in the middle, so I got a little more room. X-axis, y-axis. Here we go. A is at 1, 1. So here's point A. A is at 1, 1. Point B is at 0, 3. So 0, 3 would be about here. Here's B. 0, 3. Point C is at 2, 5. So 2, 5. Right about there. C. 2, 5. And then I'm going to connect these dots. Then I'm going to graph the second triangle. E is at 1, negative 1. So 1, negative 1. E. 2, negative 5. Here's 2 and negative 5. That's what? EF. And where's G? G is at 4, negative 4. So I'm going to go out here to about 4 and negative 4. So G is at 4, negative 4. And then I'm going to connect those. Everybody with me on graphing them? I'll take that as a yes.
Wait, my dog's puking.
Your dog's puking?
No, my dog's in my lap and stuff. It's like I'm slow.
Am I supposed to understand that?
My dog is sitting in my lap.
Oh, your dog is sitting in your lap. Oh. Thank you for sharing that. Mine is at home. Probably laying on my bed.
That's cool.
Yeah. Okay, I'm gonna tell you guys, y'all can use the distance formula to find the distance of each of these legs. And then you can compare them. I'm going to use the Pythagorean theorem to find the distance of each of these legs. And then I'm going to compare them. All right, so you can do it however you like. If you want to just watch right now and then get the notes later, you can do that. Or you can try to keep up. But I'm going to try to go, Matt's going to help me. We're going to try to go a little bit quick right here. All right, we need the distance from B to C. From B to C. So I take that and I turn it into a right triangle, just like this. All right, it's got a horizontal leg and a vertical leg. Now, my horizontal change goes from 0 to 2, so that's a 2. My vertical change goes from 3 to 5, so that's a 2. So the length of that leg, BC, B to C, is equal to 2 squared plus 2 squared. All right, or 2 squared plus 2 squared equals BC squared. So what's 2 squared? Good. 4 plus 4 equals 8 equals BC squared. So we find the square root of each side. Square root of 8. 8, square root button. I got 2.82. So BC, 2.82. We do the same thing with this diagonal leg. I'm going to drop a vertical. I'm going to slide in a horizontal. My vertical change, I go from 1 to 5, which is 4. My horizontal change, let's see, what's my horizontal change here? 1. So 1 squared plus 4 squared equals CA squared. So what is this? 1 squared, 4 squared is 16, and 1 squared, that's 17 equals CA squared. So 17 square root 4.12 or 4.12 equals CA. And then let's see this last diagonal. This vertical leg, let's see, it goes from 1 to 3, which is 2. The horizontal leg goes from 0 to 1, which is 1. 2 squared plus 1 squared equals BA squared. So that's 4 plus 1, 5 equals BA squared. So 5 square root 2.23. Okay? Yes. One more time. Is there a way to do it without the Pythagorean theorem? Yeah, you got to use the distance formula. Remember, big square root, y sub 2 minus y sub 1 squared plus x sub 2. Remember that? That's the other way to do it. There's not a shortcut. Okay, unfortunately. Now, once you have figured these 3 sides, let's see how many sides of the other triangle you got to figure. As soon as, let's do, I'm going right here first. All right, horizontal change from E to F. I go from 1 to 2 is 1. Vertical change, negative 5 to negative 1 is 4. All right, look. Do you see in the triangle up top, I got a side with 1 and 4? See it? So isn't this side congruent to this side? Does everybody see that? Because it saves a lot of work. As soon as I have matching right triangles, if I got a 1 and a 4 and a 1 and a 4, they're congruent to each other. So let's do another side. We take this side right here, F to G, and I drop in this vertical and horizontal. My horizontal change, I'm going from 2 to 4, which is 2. My vertical change, I'm going from negative 5 to negative 4, which is 1. I got a 2 by 1 right triangle. Look up here. I got a 2 by 1 right triangle, don't I? So isn't FG congruent to AB? Do you see how you don't need to do the distance in the second? All right, so we're just going to check the third one just because I want to check the third one. And let's see, we are going to put in a horizontal and a vertical. We're going to turn this into a right triangle. Our horizontal change, it goes from 1 to 4. What is that? 3. Do I need to do any more? Didn't this triangle have to be a 2 by 2? Instead, it's a 3 by, our vertical change is 3. It's a 3 by 3, isn't it? Is a 3 by 3 right triangle going to have the same hypotenuse as a 2 by 2 right triangle? No. So, are the triangles congruent? No. And if you want to, you can say the sides, all 3 sides are not congruent. Okay? Or you can say no, side. What is that side up top? BC? BC is not congruent to side EG. All right, 2 out of the 3 were congruent, but the third side was not congruent. Okay, the second theorem that we need to cover. Side angle side congruence. This is real important here. And side angle side congruence states that if 2 sides of one triangle, check that, if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the triangles are congruent. If 2 sides in the included angle of one triangle are congruent to 2 sides in the included angle of another triangle, then the triangles are congruent. That's called side angle side. SAS, side angle side. Side angle side congruence would look something like this. Here's side, included angle, and side, congruent to side, included angle, and the side. What's extremely important here is the words included angle Do you see how the angle that is congruent is formed by the two congruent sides? The angles that are congruent are both formed by the two congruent sides. That is what an included angle is. When you're dealing with side angle side congruence, the angles that are congruent have to be formed by the two sides that are congruent. See it? So this is an example of side angle side congruence. All right? And a congruent statement here would be triangle ABC is congruent to triangle. All right, again, if we went ABC on the first description, ABC. All right, we went from the congruent angle first, right? So we got to start with the Z. We went from congruent angle through one tick mark. So we got to go congruent angle through one tick mark. So we got to go ZY. And then there's only one letter left, and that's the X. That is side angle side congruence. Now, I want to show you not side angle side. All right? Here's a couple of triangles that, or a couple pairs. Watch. If we got triangle on the left, triangle on the right, and we get this picture. You see the difference? You see why those two triangles are not congruent by side angle side. The triangle on the left goes side angle side, doesn't it? But in the triangle on the right is angle A, the included angle. The triangle on the right is triangle A, or is angle A an included angle? It's not, is it? It's not formed by the two congruent sides. That wouldn't work. That is not side angle side. Here's another picture of not side angle side, okay? Oops. In the triangle on the right, our angle is included. It's formed by the two congruent sides. But in our triangle on the left, the angle is not the included angle. The congruent angle is not the congruent angle. So both of these, this right here, that gets a this. That gets a not congruent. And this over here, this gets a not congruent. Let me show you a couple of things. I don't necessarily want you to write these down right now, but I want you to watch and absorb. Understand? If you get a picture like this, okay? And that's all. Let's say you get this in the picture and you get this, and I don't know. Let's say you get that in a picture. Is there anything else that you know about that picture and those two triangles? They've got two congruent angles, right? But do you see the two vertical angles right here? Aren't those congruent as well? You're going to start to be given pictures that look like this, all right? And you have to understand / assume that those two are congruent to each other. You're not going to be told they're congruent, but by rule, they're vertical angles and they're congruent to each other. So you will have to be able to identify pictures like that. If you see this, okay? If you see this, all right? Do you see this side that goes right down the middle here? If I call it AB. Does everybody see that that's the vertical side for both triangles? Isn't that side length going to be the same in both triangles? Okay? But you're not going to get a tick mark put on it. And somebody's not going to tell you that AB is congruent to AB because it's in both triangles. Okay? So you're going to have to realize that when you see that picture. All right? So those are a couple of examples of some things you're going to see in your practice today that you just need to understand that by rule, if AB is in both triangles, that it's the same length in both triangles. Okay? All right. So here's your practice for today. Page 49. You got 1 and 2. You got page 50. You got 1 and 2 again. And then you got 4 through 7. And I need you to check focus for homework. Hopefully I will. Now listen. On page 50, problems 4 through 6, it says determine which postulate can be used to prove that the triangles are congruent. Determine which postulate. That means side, 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 or side, angle, side. Okay? Those were the rules that we covered today regarding triangle congruence. Those are called postulates. Sometimes they're called theorems. All right? Postulates and theorems are rules in geometry that have been proven to be true. You cannot question their truth value. Understood? All right. All right, you've been a great audience today. At this time, we're going to end the Zoom meeting. I will post these notes to YouTube shortly in case you missed anything. I know we went a little bit fast today, but first period is going to be over. First block's going to be over in about 7 minutes. Haven't you guys been in here for 2 hours so far this week? Monday and Tuesday? Yeah, so I think you're only in here an hour today. So I need a, let's see, what am I doing here? I can stop the recording.